Okay, we will go now to our third example, and it looks like it is an exponential regression, but I will still show that it really is an exponential regression against a linear and quadratic regression. So the problem tells us that this is a problem regarding a soup that's left on a countertop to cool in a span of 10 minutes. And of course, whether you do something about the the soup or not, the temperature is gonna go down. Okay, so first is we input our data using our table. That's 0, 2, 4, 6, 8, and 10. And then of course our y is 180.2, 165.8, okay, 146.3, and then you have 135.4, and then you have 127.7, and then you have 110.5. Okay, now it looks like it could be anything. It could be a linear, it could be quadratic, or it could be exponential. But which is the best of them? So let's try doing it first with a linear regression. So y1. Okay, and I need to consider that my line is going to the left side. So therefore, my a should be negative, ax1 plus b. Okay, and it's also best free because our regression analysis tells us that the equation y equals 6.767 plus x plus b plus 178 could be fit for the equation because it has a 98.56% fit value. Okay, however, let's see the quadratic. Now let's see, for example, I'm going to make use of a quadratic regression. Now I'm going to make my a positive because it seems like the parabola is going upward. So we have ax1 squared plus bx, don't forget the subscript of x, plus c. Okay, and it looks like it's also a fit equation better than a linear equation because compared to linear equation, which is 98.66%, this is about 98.97%. Okay, so it means that it could be a quadratic function. It's not going to be, it's better than a linear function. Now let's see if it's going to be an exponential function instead. It has to be greater than 98.97%. So you have here b raised to x1. And as you can see, our r square is 98.99%, which is actually greater than 98.97%. So the best fit for our model is about this, is this equation, meaning our equation is y equals 180.325, okay, times 0.953959. Now, notice that I did not consider that my graph is going to the left side. In the case of a linear, of an exponential function, you don't need to put your a as positive or negative, okay? So just put it as positive, all right? And as you can see, it will fit our model. And of course, okay, looking at this, you can actually assume what is the temperature of the soup after 3 minutes because it's not included here. So what we can do is just copy this and then just change our x to 3. And the temperature of the soup after 3 minutes is about 156.55 degrees Fahrenheit.